I want to focus on some aspects of rehabilitation robotics with some link to some social impact and outreach events at the end, but start with some scientific aspects. So my team is comprised by almost about 40 scientists and also administrative people. Here you see most of them. These are mainly the scientists. And we are located at 3 main spots. That's at ETH Zurich, which is my main affiliation. But as a professor of medicine, I'm also having some people working in the hospital, in the research campus building. And we also have opened a lab, a new lab, about 3-4 years ago at the famous Swiss Prof Center. It's a clinic for spinal cord injured patients. Also, Samuel Koch was treated there, for example, after his accident at Wetten Das. And here we also have a lab about AI applied to disease development and prediction of symptoms. So our work is focusing on investigation of human motor control. We develop mechatronic devices such as rehab robots and assistive devices, and we research about the interaction between the machine and the human. And the target population, not only, but the main target population are spinal cord injured patients, where we have rather high prevalence. But another even more larger population are people with stroke. The incidence rate of stroke is about 200 times or 100 times higher than with spinal cord injury, and increasing because of there's a link with age. Age is a risk factor for stroke. And here we have a lot of studies. We did a lot of studies in that population group, but also with many other different kind of patient populations, also in the field of orthopedics, for example, depending on the project. But when we focus on neurorehabilitation, when rehabilitation is rather new, there was already rehabilitation, some kind of therapy 300 years ago. But rehabilitation was mainly focused on people with orthopedic problems, with amputations, maybe also with cerebral palsy. But people did not know that the nervous system is so plastic that an intensive therapy is really beneficial for improving gait or arm function and quality of life. That changed about in the 90s when researchers figured out that the nervous system is quite plastic. It's worth to do intensive therapy, but that time this was mainly done by physiotherapists and occupational therapists. There's, however, a challenge. Yeah? Most of the time, still nowadays, in modern times, the people are most of the time not active. When they are hospitalized, they have spent a lot of time for sleeping, also important, maybe for eating, watching TV, talking to relatives and doctors. And only maximally 10% of the time is movement done, which is beneficial for the recovery of the motor functions. And it's difficult to get more, even here in healthy and wealthy countries such as Germany or Switzerland, because it costs a lot and time is not available, and personnel staff is also not available. Although we know that intensive training is important and a must to learn movements from our young ages, our children. So when they do running movements, before they start to run, when they lying supine and strampeln with the legs, they do up to 26,000 leg movements per day. When they start to move, children do about, when they start to walk, 14,000 steps per day. And they always try to grasp things. That can get a bit annoying if you have children. So they go up to 2,400 reach and grasp actions every day. And it still takes 2 to 5 years until these little children learn secure, robust movements and gait. And so we cannot expect, if a person loses some motor functions after stroke or other injuries in the brain, that they learn movements with therapy 1 hour per week over 1 month, or even 1 hour per day is not enough to learn movements. We have to get to much higher doses of movement therapy to show an effect. And that's one of the most limiting factors nowadays with rehabilitation robotics. Robots can help to increase this doses. And since about 20 years, robots are commercially available. And many of them now going more to the wearable side, going more to assistive functions. And all of these machines help to increase the doses. Such machines are, for example, the Locomat. which was not, I'm not the main developer of the Locomat. It was Gary Colombo and Volker Dietz, but I contributed when I arrived in Zurich 2003 with some controllers, some gamification things. The body weight support system was developed in my lab. And that's a machine which helps to increase the doses of gait therapy. And we also can increase the doses even more by motivating the people, by getting high engagement level, reducing their compliance so that they are coming to the therapy and actively participating to the therapy by using such kind of virtual reality scenarios. That was, by the way, developed together with my former PhD student, Alex König, who's now also a professor here in Zurich, in Munich. Then there are many devices. Yeah? Many of them are only in the labs. These are some older devices. Some of them are commercially available, such as the Gait Trainer, GEO, Terra Trainer, and many more. And there have been some studies showing that there is an effect. Many studies, hundreds of studies. There's also some nice meta-analysis from Jan Meerholz and team. That's about 6 years old, a study comparing all the studies for lower extremity therapy. Actually, 62 trials he was involving. This group was involving with more than 2,400 participants, stroke patients, chronic stroke patients. And this kind of robotic devices showed that they are more likely to achieve independent walking than people who are not using such kind of devices. But more important result of this study was that people in the first 3 months after stroke and those who are not able to walk benefit most. That's a very important message because we have to find the right target group to get a response. If you just take people who can already walk, the effect is little. And there are studies showing or claiming that Locomat doesn't help, but they have taken the wrong patient group. So it's very important that you carefully choose the right target group for any kind of treatment. Then upper extremity, that's the Armin device, which I developed in my lab, the first exoskeletal device used for therapy. And the latest version has 7 degrees of freedom. We have a new device called NEXO, developed together with Marco Hutter in Zurich, which has even 9 motors to better cover the complex kinematic and biomechanical structure of the shoulder. And this is also developed for training, for therapy. There's also a commercial version, which is sold in license by Hokoma about that device. It looks a bit different, but it has the same function, same target group, other different games, but the same controllers behind. There are many more devices also for the upper extremity. The first, not the exoskeleton, but the first Rehab robot applied as this end effector-based structure is the MIT Manus, developed by Neville Hogan and Igor Krebs in Boston at MIT. And the other smaller, simpler devices, exoskeletal devices, as well as end effector-based devices. That's also a passive device without motors from Hokoma. Some research devices from Marcy, O'Malley, David Reinkensmeyer, and Armin again. There's another study from Jan Meerholz, a bit younger, no older, 2018, 45 trials involving more than 1,600 patients, also chronic stroke patients, and they found out that this kind of robotic training improved activities of their living scores, arm function, and arm muscle strength, and the quality of the evidence is high in that meta-analysis. That's again the device. We developed a lot of patient interactive strategies, which involve participation of the patient, assist as needed, patient cooperative strategies, responsive strategies, how you can call them. More or less it's all the same. It's important to train task-specific things like activities of their living. For this, we need some kind of a screen. We cannot use real objects, of course, but using some virtual gamified representations, it's easier to switch, to adjust the difficulty level, to motivate the people. That's an important study which we did about more than 10 years ago already with the Armin. It was a multicentric clinical trial, randomized clinical trial with finally 73 patients who finished also the follow-up phase. We had 2 groups, one robotic group for training, one conventional group, which were trained with conventional therapy. And we had them trained 8 weeks long, 3 sessions per week, which is not so much if you compare with the children. So 3 hours per week only over 8 weeks makes 24 sessions. That was therapy time. and then they follow up with 2 assessments. And you see that the robotic group, which is the black line, has a higher outcome in the Fugl-Meyer score. That's an impairment level. It's rating the impairment level of the patients. So it was a significantly higher increase here. It seems to wash out over there, but that was statistically not significant anymore. That difference is significant, but the difference is small. It's only 1.2 points on that scale out of 66 points. That's clinically not meaningful. But already after half of the therapy time, we get the same value as with the conventional group at the end of the therapy. And maybe if you would have done the therapy longer, or also with higher doses, so more sessions per week, I'm sure that the difference would be much larger. And what's also a very important result is when we select just about half of the patients who were more severely affected, who needed more support for therapy, but also in daily life, then the difference was larger. And that shows that kind of actuated heavy machines make more sense, both the Locomat as well as the arming device, make more sense to train with patients who are more severely affected. Then what we also did to improve engagement, that's 20 years ago. We connected 2 machines over a certain distance that people could play games together. And we call this, we want to give social reward. And gamification is also rewarding people, giving points, giving to another level, changing the scenery is a reward, a positive reward. They even studies by Andy Luft where they give better food or money. That can also be a positive reward. And another kind of award is a social reward, that people play together, that can talk together, that can have fun together. And we did this in several studies with 1 or 2 PhD students work. And here you see now 2 of the armings with 2, these were students getting connected. And we, for example, compared now 3 modes. We let the people, healthy people in that study, play alone and give them also an alternative option to play together. And when they played together, they could play in a cooperative mode against the computer or in a competitive mode against each other. And then we asked them, what do they prefer? And out of 30 age-matched people, it was elderly people, but no stroke, healthy people, most of them, so 28 preferred to play together in a competitive or cooperative mode. And only 2 were maybe these nerds, they preferred to play alone. And another nice, since machine learning is quite popular right now, we could also find a classifier which was able to predict, before we were asking what they would like to play, was able to predict what kind of game they would like to play based on inputs such as age, emotional stability, based on standardized questionnaire, competitiveness, and co-players' extroversion. Then another project which we did is to exploit the advantages out of the robot and the therapist. It's not the goal to get rid of the therapists because they're still better than the robots, but the robots have an advantage. They have more force and higher endurance. That's basically what we try to get there from the patient, from the therapist. We get the humanity. Most people prefer to have real therapists involved rather than robots, but the robot is stronger and has a high endurance. Now we combine everything so that for example, the therapist is now touching the robot, but the robot behaves mechanically transparent so that she is feeling the mechanical properties of the patient arm, the weight, spasticity, spasms, if the patient is contributing or not, she can feel this. And but for this, robot needs to be very transparent, which can be reached by different methods. Yeah? You could make it lightweight, but that was not possible. The moving parts are more than 20 kilograms. You can add serial-elastic components or parallel elastic components, or develop special controllers. We did everything combined, also special controllers based on some observers. Computer talk methods did not work so well. It was better to develop a special observer controller. And then we could reach a transfer behavior. That was a healthy guy, my former student, Fabian Just, who's now professor in Ulm. He's moving it easily, 20 kilograms, because this transparency mode helps to make the machine mechanically transparent. And then we did a following study. Yeah? We called it the bridge therapy. So the hypothesis of this therapy was that the support and resistance of the therapist during conventional therapy can be taught to the robot so that it can imitate the therapist. So that what we did is the following. So the therapist can, of course, therapy the human arm of the patient. Then we told the therapist to teach the robot how to move the arm of the patient. And she did it here together with the human arm and the robot arm. The robot did learn from the therapist and then perform the movement. In this way, the idea would be that we have a robotic rehab gym with maybe 4 or 5 devices, 4 or 5 patients, and only one therapist teaching the machines, going from patient to patient, and having a more efficient therapist-patient interaction. We also then validated this. It was a documentary with NHK. That's the first phase where the therapist was teaching the robot and the patient arm. Now it's the robot alone doing it. That was the third condition. And what we then figured out, we compared the EMG patterns. So we measured kinematics, some movements, just to control that the patient doesn't deviate too much from a standard posture. And we measured then the EMG patterns in some muscles. And then we compared the EMG patterns between the 3 different conditions, without robot, with robot and therapist, and with the robot only. We see that the differences are all quite low, but the best was when we compare between the 2 robot situations, one with the therapist, one without the therapist. So that seems to work. It's kind of making the therapy more efficient. This, what I said so far, was all about using robotics in the field of therapy to train, to improve the biomechanical function of the patient, and maybe in this way also the quality of life and participation in society. Another large field of rehabilitation engineering is the field of assistance, yeah, to provide technology to support people in daily life, often without changing or improving any kind of body functions. That includes devices such as wheelchairs, crutches, walkers, but also glasses, hearing aids, and so on. Here we did a lot of different things. One was already 15 years ago. We developed a powered knee prosthesis. That was a project done by my former postdoc, Heike Valeri. She's now professor at RWTH Aachen. She developed special controllers for prosthetics. Then in the last years, we were partners out of a group of 4 teams developing the racing wheelchair of Marcel Hook, who got now several times gold medals at Olympics and World Championships in para races. And here we developed ergometer to optimize the posture and mainly the posture of the parathlete while sitting in a newly conceptualized, newly designed wheelchair. We also developed orthotic devices such as a Myo suit, which is exoskeleton structure, but a soft exoskeleton. That's why we call it Myo suit for the legs, where we used just 1 tendon, 1 motor per leg. It's an under-actuated system because we have only 1 motor supporting the hip joint and the knee joint, and there are relevant phases during gait and also stair climbing and standing up where we have enough synergies between both joints. 1 motor can indeed support both joints simultaneously. So we have 2 motors, of course, for the left and right leg, and could show that gait function is getting better. In many different kind of patient groups, we tested it in stroke, in spinal cord injury, people with orthopedic lesions. We developed versions for children, which still are being tested in our children's hospital. And we just finished some studies with the Charité in Berlin with the Heart Center, showing that we can improve the conditioning or we can avoid the deconditioning of cardiac patients with heart failure. We transferred the technology to the upper extremity using also a tendon. Here was a Bowden cable, the first version, driving only the shoulder joint so far with this tendon principle with following argumentation. Target group are mainly stroke patients at the beginning. And first, when you bring the shoulder to this horizontal position, Then you can move the elbow in the horizontal plane with no problem of gravity, so that we can increase the functionality of the arm only by actuating the shoulder. Plus, in stroke patients, many stroke patients suffer from some kind of abnormal synergy patterns. If you ask a stroke patient to do this movement, an abduction movement, they will flex the elbow joint. It's neurologically coupled. So it hinders them to reach the hand to grasp objects because they're always flexing the elbow. But it has been shown by some studies from Jules Dewald in Chicago that if you're on the horizontal plane, that this synergy is less. So we can kind of set the elbow free from this abnormal synergy by only actuating the shoulder. We further develop it. The newest version now is 2 motors to support both shoulders, and now we are on the phase to change the concept, to use both motors or even more motors maybe to actuate only one arm for different target populations. So we now want to support patients with cerebral palsy, children, but also adults, using a new concept of such device for one arm only, maybe mounted to a wheelchair, because many patients, the more severe ones, are in a wheelchair, and the wheelchair is a great device to connect something, maybe even to provide stronger power, stronger batteries, and then we have less challenge also with connecting the device maybe to the patient. Yes, here a short movie about this device from Adrian Esser, who finished his PhD.
Imagine a jacket that gives you extra strength, helping you lift, move, and go about your day with ease. This is the MyoShirt, a robotic exosuit designed to support your shoulder muscles. Unlike bulky exoskeletons, the MyoShirt is lightweight and portable. You wear it just like a jacket, and it uses cables, like the tendons in your body, to assist in moving. Sensors detect how you move, and motors adjust the tension in the cables, giving you just the right amount of help. Most robotic assistive devices are rigid and heavy, but the MyoShirt is different. It blends into your clothing, moves naturally with your body, and adapts support in real time. Whether you're reaching, lifting, or taking your dog for a walk, it works alongside you like an e-bike for your arms. This technology can help people with muscular weakness, those undergoing therapy or rehabilitation, or even healthy people who need endurance for long tasks. From daily activities to recovery, the MyoShirt makes movement easier. Wearable robots like the MyoShirt could change how we think about mobility, bringing strength and support to those who need it most.
Okay. So it was Adrian Esser who just finished his PhD thesis a month ago in my lab. And what I have to admit is the following. We tested the device about 2 weeks with 2 patients at home as an assistive device. And they said it's functional, okay, but the acceptance was not so high because it's inconvenient. It takes a while to put on, to put off, and maybe the benefit is not worth all the effort. And I think there's a lot to do to improve this. But what I want to say in general, when we have assistive devices, especially when they're powered, they are challenging. If you have a powered device, the question is, how should the motor know what the user wants to do? If you have a powered prosthesis, it's a problem. Most lower extremity prostheses are not powered because the body, the human, can move it ballistically using momentum. And gait is a periodic thing. So it's very easy to use ballistics to make it run. As soon as you add a motor with a transmission, it's not pedaling ballistically anymore. So the motor has to be active all the time. And it's getting a control problem and also a safety problem, because then the prosthesis must work for each step. And if you do your 10,000 steps per day, even 1 per mil failure rate would mean maybe 10 times falling per day. So it's a big issue, and that's why probably there's no successful powered knee prosthesis commercial available. Foot prosthesis is a bit better, but there's maybe the safety issue is not so big. Other problem, you need a battery as soon as the power, and that can make the device heavy and bulky. And these were the main driving forces why I said, okay, we have to improve the technology, because all these challenges led to limited acceptance of these devices in the field. People with the best advanced robotic prosthesis, if they can afford it, because insurance doesn't pay everything, also not in Switzerland, they were ending up in the drawer because they're too complex to use. Functional benefit was limited. And that brought me to the idea of organizing a competition, inviting the best teams of the world from universities, but also from industry, to join the CYBATHLON to showcase, first to develop, but also then to showcase best technologies. These were the first ideas which I had 2013. I thought we can go to certain racetrack with different obstacles which are relevant to daily life, and then compare the performance of lower leg prostheses, exoskeletons, powered wheelchairs, and so on. Then a year later, we spoke to people from television, how to get it, to make it exciting and that people in TV also can follow it. Then we came up with 4 races where 4 pilots together race simultaneously to make it more entertaining for the audience. And we had the first rehearsal 2015 in that stadium where it took place several times without public. I mean, there were people watching, but this was mainly media and some teams joining to test out the things, to produce some media coverage. And then we had the first CYBATHLON 2016 with a sold-out stadium, 8 hours live on Dreisat, so people here could see it. Also SRF1. We had a lot of media present, about 200 media representatives in the stadium, and great teams. That's the team Angel Robotics from Korea getting the bronze medal. One team from the States, and then Rewalk from Berlin were better. Rewalk got the gold medal. 4 years later, Rewalk didn't want to come again because they could only lose. They had a gold medal already, but they then got gold 4 years later in Korea. And 2 years ago, when we had this event again, they got again gold, and they participated with a company they have founded to sell a device. So that time we had 4 different disciplines: powered exoskeletons, knee prostheses, arm prostheses. They could also be body powered with a sling on the other side. It doesn't need to be a motor. Then powered wheelchairs. They needed to be powered because here we assume that the pilot has a high lesion, that they need a powered wheelchair. Then FES bike race and the brain-computer interface race, where we developed the game. And the people came with their software and their hardware, the AEG or FNIR's hardware, to drive the avatar of our game. And teams were coming from 25 different countries. 66 pilots were eligible to join. More came, but some we had to disqualify because they were too little or they didn't fulfill the rules. And all continents were involved, but not Africa. And then, sold out stadium, great atmosphere, was very loud in the stadium. TV, and that was a picture of the year from BBC for the month of October 2016. There's even a stamp which came out in Sierra Leone. We got several prizes for the CYBATHLON, and we repeated the event 2020. Of course, it was in the middle of the pandemic. We had to make a remote event with teams, with hubs joining in their local spaces, in local maybe stadiums, but empty stadiums. So people were not allowed to organize public events and even not to travel. But we could organize it in this remote structure. There we had then, again, many countries involved. Now it was Africa joining, but not anymore Australia. But I can spoiler you that last time at the CYBATHLON, we had then all continents involved. And 32 hubs were involved. You see, for example, some of the hubs here. Also in Zurich, we had a hub with all the media, thousands of people cutting the movies, which we got from the races to show them in a partly offline but synchronized way to figure out who was the winning team. And it also was still a success, but less emotional because there was no real audience. We got also many mentionings in Guinness World Records books. And that's, now you see CYBATHLON 2024. We had, but that was similar in the years before as well, 80 teams from universities, 15 from companies, 5 from other organizations. Again, in this year's Guinness World Records book. And you see now all this media. That's just a small fraction from all the TV stations, but also famous newspapers involved. Yomiuri Shimbun is the biggest newspaper in Japan. And we also did well with publishing things in journals, and you will see more about this. Just last year, in November, there came out a longer article in the New York Times about the CYBATHLON, the BCI race. And now we did a study in my lab with a student and my colleague, Peter Wolf, where we now try to collect all these numbers from media, from scientifics, from the teams, and compare the numbers. And they show now these new results. So what we were counting, for example, was how often was CYBATHLON mentioned in the media. And in media included web pages, print, newspapers, also TV, radio. And we counted almost 7,000 articles, and 1/3 of them even had the term CYBATHLON in the title. And we even applied, when in some languages, it's not so easy to search, because the font, the letters are different. But we also translated, for some countries at least, we used other fonts to also search it, but it's still not inclusive. Probably, I guess there are many more articles which we didn't find. But still a nice number. If you look more carefully, there was a higher peak in the years of the CYBATHLON because, of course, there was more media presence in these different sources. Then we also checked the literature, the scientific literature. There were several special issues, 4 or 5 special issues with several papers about the CYBATHLON in different famous journals. And what we figured out here, there are about 300 scientific publications. 2/3 of them are journal papers. And about 80 of them even have the term, 80 of the 300 have the term CYBATHLON in the title, which is nice. And half of them only in the body of the paper. The teams coming from different countries, you see it here. Most teams were from Switzerland, but second one, Italy, welcome. But then France, Germany, South Korea, Japan with 7. And you see here, nice distribution, all continents involved. Then we did also a survey with the teams. We sent out surveys to all teams. With some reminders, and we got a response rate of 76 teams out of about 130 or so. So it's a response rate of roughly 60% maybe. Many answers, but the most important ones, 80% almost said that the CYBATHLON pushed the development of their prototypes. 50% said that their device showcased at the CYBATHLON is now really available on the market. And some companies were established thanks to the CYBATHLON, or the establishment was facilitated thanks to the CYBATHLON. And there are some of these companies you see, 8 companies. Twice is an exoskeleton company from Lausanne. Skevo is the wheelchair which can climb stairs on 2 wheels, and a chain, Swiss company selling devices now, and some more, very small companies. Then there were already 21 established companies who joined the CYBATHLON, and some of them used the event to release new product versions, like Otto Bock, Össur, and other companies, and otherwise used the CYBATHLON to advertise their products. Like Rewalk, Hausomit produces FES stimulators, and also many teams received additional funding thanks to the CYBATHLON for the development. Then, after we had the CYBATHLON, which was successful, also within ETH Zurich, the president of ETH and the head of the foundation of ETH said we should go ahead. We should do more, not only to do something for inclusion, but also to do this kind of science or this work in science and education and outreach. So we formed a competence center, which is a rather loose, not a physical, but a structure which is orthogonal to the different departments or faculties. So we have 16 departments, and some professors working in rehabilitation science from different departments did join this competence center. So we have about 80 members from ETH, but also some also University of Zurich mainly. And we do now, here you see now, structure. We have a steering committee, advisory board, the General Assembly with 80 members, and partner companies who were supporting it financially. And thanks to this event, we could now establish a lot of new projects. We could get funding, more than 30 million Swiss francs, to establish new professorships. One just started, or will start very soon, in health economics. We have a lab now, which is run by me, at the Swiss Paraplegic Foundation. We have professors at the clinic. We have a professor for architecture care and barrier-free environments, and also a professorship in a more technical field. We also established a new major in rehabilitation and inclusion, where people have to take subjects not only in rehabilitation technology, but also rehab medicine and inclusion. And we organized different outreach events. For example, an exhibition called Mobility and Inclusion, where people who can walk, can take a wheelchair and then try out some kind of challenges. Also learn general things about wheelchairs, about exoskeletons, about crutches, about spinal injury and different kind of diseases. And here, for example, they could use the wheelchair as a controller to drive a Mario in a Mario Kart game. And they could even steer the Mario Kart by steering the wheelchair and so on. Then we also do a lot of different kind of other events, which refer, for example, to inclusion, not only, but also to inclusion, different events and conferences. And I had the honor to become a Thomas Mann Fellow last year and live 4 months for free in the house of Thomas Mann, who got the Nobel Prize in Literature 100 years ago. And he was building that house, living part of his exile there, and now it's owned by the Auswärtige Amt, so by the German government, and they provide this for their fellows here, and that was organized also a podium session here. That's the living room of Thomas Mann. Lorenzo has seen it because he was visiting me. That's a real piano, 100 years old, from Thomas Mann, and yeah, that's the house where I had the honor to live right here. And I was doing a special project there. I was interviewing different people in my field, but also in other fields, including also people from movies, actors, directors, musicians, journalists, composers, and was asking them about their experience, their hopes, their fears about robotics and AI in the society. And yes,
they were living around the corner. All this.
Yes, my neighbor was Goldie Hawn, and some blocks away there was Steven Spielberg and Tom Hanks. And then I did ask these questions to them and summarize them. And some of these questions were also referring to rehabilitation. So the question was, the project is called AI to AI. Is AI a tool for inclusion, more or less? And the difference was the answers were very different, very diverse answers in general. So I had about 50 protagonists asking, and I got like 50 different opinions. So those people who think is a good thing, for example, was Helge Fußt. He was also a fellow there. He was the head of Tagesthemen until March or so, or February this year. Now he's the head of Die Welt and some journals. But he said AI offers journalism the chance to reach broader audiences by tailoring content and using simple language, making information more accessible to people with migration backgrounds, language barriers, or cognitive challenges. Then Bistra Dilkina, she's a professor of computer science at USC in LA. She was more skeptical. Many AI systems are trained on biased or incomplete data, which can reinforce harmful stereotypes and disproportionately impact those already at risk. Some more answers. Vanessa Chang, she's director in a magazine. Yes, there are numerous innovative technological developments that support people with disabilities, such as speech-to-text captioning, One early example is the DevNet demonstration project launched by Azure International already 1978. Vanessa Chang, she's the same. Yeah. She's also critical. AI may only replicate Ableton and therefore resulting to inaccessibility. We should try to solve this by better including people with disabilities, creators, designers, engineers, and user testers. If you're interested to read more about these statements, I was lucky to find a publisher. Will come out a book called Eye to Eye in a month or so, available on Amazon. Then you can read more about these things. And now I finish with a short movie about the CYBATHLON, about the last event of the CYBATHLON, to finish my talk.
This is a race. You have to keep going.
Whoa!
A pilot. Oh!
Oh, and he is getting a little bit frustrated with himself here.
Oh! So close.
Well, I give so much adrenaline, so yeah, time seems to go a bit shorter.
It is not only difficult, but also challenging and stressful.
That is a thrilling finish to BCI, but super, super close. My goodness.
Wow, that was crazy.
The technology is like next level.
Spectacularly impressive to watch.
Oh, look at the excitement and the
reaction
team
at the
coming
end.
together.
Thanks very much, Robert. It's a huge compendium of research and innovation, also with the CYBATHLON. I mean, it was his original idea, 100%. I know there's no one behind. It's just him behind all this, let's say, well, huge effort also outside the lab that has been done. And it's quite unique, I think, university-wise. Most majority of professors, they stay in the lab. But I mean, he has the chance to and the capacity just to outsource everything. Many questions, several questions.
Yeah, fascinating. I really like your CYBATHLON idea. And so in your movie, it was shown, I think it was from Pittsburgh on the BCI challenge.
Yes.
This guy had an implant, right? A Utah implant. The others seem to have EEG.
Yes.
This is probably so invasive versus non-invasive. Are you going to keep that in one, or are you going to separate them?
Very good question. He was the only pilot having an implanted system. The years before, we did not allow it. We want to avoid some too much crazy inventions and risk for the pilots. But then we allowed it, and it's an ongoing discussion. On the one hand, the philosophy is that the teams should be free in developing anything which is beneficial to the people. And we just try to keep the inclusion criteria the same. So people should have comparable impairments to make it fair. It's like the Paralympics. But now people start to ask, of course, I mean, the other people start to maybe get angry because they see they have an advantage. It's the same with the implanted FES guy. There's also one guy who has an implanted system, and he also got in the first race the gold medal. And now we think about splitting it, or at least having one race together and having separate rankings. But then the question is, do we have enough for that race? There are not so many pilots.
Next, Angela.
You ended with the AI, but what is your personal conclusion for your research now for AI, and how much can it help rehabilitation?
Yes, when my opinion, or to make a conclusion out of the book, an interview is difficult because it was so diverse. But I'm of course biased as an engineer and scientist, so I believe in technology, and I think we can reach so much. We can apply AI in a way that people with disabilities have a great benefit with a speech to text, with there's so many devices where people with motor disabilities and seeing disabilities and hearing disabilities can benefit from all these smartphones and so on. And I think it is improving. Of course, it can be misused, or we might develop. They're already with all this AI, there's already bias in the database that is on the disadvantage for people. But if we see this problem, we should try to solve it. And we are in I can make it easy. As a scientist employed by university, we can make it easy saying it's finally also the society and the politicians which are in the responsibility. It's not us alone. Of course, I would not say I want to develop something which is bad, but my intention is to do something good. Maybe just figure out results for our science community, but sometimes it could be something which gets a product, and then it should be together with the society and all these organizations to make it useful.
And is it embedded in some of your devices already?
Yes. Yes. The I use is quite standard controllers. We use reinforcement learning, for example. We use model adaptive control with some neural networks and so on to make the motor function of devices better. Now in a new project, we also try to use speech input for therapists, where we use large language models, commercial ones, for the use of the machines. Quite, I would say, nothing special.
Yeah, at the beginning of your presentation, you mentioned that infants get a lot more practice than people in rehabilitation, and that we should be aiming for.
But say again, who has more practice?
Infants, young children.
Yes.
And that we should be aiming for a lot more hours of practice and a lot more repetitions.
Yes.
For persons in rehabilitation. Is there an ideal, something we should be shooting for, like a dosage that you think would provide the best results?
Yes, there's not a number. So most people say as much as possible. And I would say if you have an impairment of a limb due to a stroke, then I would go for several hours per day. But there are limiting factors. If you do the practice too early, it can have also negative effects. If you do too much training, it's like in sports, it's maybe not healthy anymore. You can get also skin irritation from all the cuffs and so on. So there are limitations. But the biggest limitation is cost and personnel.
I'm curious about the CYBATHLON. So you show the numbers of big outcomes in terms of development of systems, establishing companies, and there is also the big target of promoting inclusion. Yes. What is, in your opinion, the biggest achievement that you see of the competition?
Yes. So for me personally, biggest achievements are that it's a topic in our community. Many people, so you like to join, form student groups, and then we meet at conference. We will again organize a CYBATHLON conference in Singapore. Next event will be in Singapore, maybe in 2 or 3 years. It's good for our community. And the second goal, actually, the main goal for me was always to do something for inclusion. Here it's just very difficult to measure the outcome. So if there are a low number of people who we could open the eyes, produce some awareness for people with disabilities, to show them these are just normal people, members of our society, then it's also successful.
Yeah, so we have a very good example on that. That's cochlear implants.
Yes.
And yeah, you don't include them. Maybe that's a good idea.
Yes. In the last CYBATHLON, we had the first time people with sensory deficits, people with seeing disorders. We could also organize a certain event for people with hearing disorders. It's just a bit tricky to define a new discipline. Then should be a community. If all come with a cochlear implant with similar performance, maybe it could be not so interesting. And yeah, it's it should also be interesting for the audience. It's a bit challenging that we do not trend to drift towards a freak show. It should still be an honorful event for the pilots, that they are the stars. That could have been a risk also with the blind. If the blind people run against the wall, it could be maybe funny and the people are laughing, and we want to avoid such things, of course. So it could be potentially a race, yeah, but yeah.
So I've seen one of the person raising, I don't know what system that was assisting.
Yes.
What about including in this device or let's say assistive systems, also humanoids, that right now is just quite a big issue?
Yes, good thing. At the next CYBATHLON in Singapore, we will have an assistive race where humanoids could support. Thanks.
You anticipated everything, of course. If there are no other questions, let's thank again Professor Riener.